So part one of today's lesson is we're going to look at simplifying with rational exponents, also looking at simplifying expressions that involve radical symbols. So before we start looking at simplifying expressions that involve rational exponents, so fraction exponents, we first have to review properties of exponents. So when we have two of the same bases, so we saw that lower part called the base, but with different exponents and you're multiplying them, we would add the exponents here. So that would become x to the a plus b power. When we're dividing, again with the same base but different exponents, that's when we subtract the powers, and specifically it's the top power minus the bottom one, so that would be x to the a minus b. When your exponent is outside the parenthesis, this is when we multiply those two exponents together. So the answer there would be x to the a times b power. The two ones that students usually get mixed up are these two, whether you multiply versus add. So a good way to remember it is if it's outside the parentheses, that's when you're going to multiply them. So then the next one has a combination that not only it's outside the parentheses, but it's sort of like a distributive property that you have to distribute that power of c to both of those terms. How many terms are inside there? You have to do it to both. And when we do that, we're multiplying those exponents. So the answer becomes x to the a times c power and then times y to the b times c power. Same with the next one to the right. If you have a division, again, this is same for division problems where you distribute that power to both terms and we're multiplying because it's outside the parentheses. So the answer here would be x to the a times c power over x to the b times c power. So basically you're distributing the power if there's multiple things inside the parentheses. And then the last two are pretty quick. The last one just says if you have any negative exponents, remember you can always write them as a positive exponent by sort of writing the reciprocal of it. So x to the negative a is the same as 1 over x to the positive a. And then anything to the 0 power, even if you don't believe me on your calculator, is going to be 1. So even if you took 216 to the 0, that's going to be 1. So make sure you have these properties listed somewhere in your notes, because we're going to be applying them here in a little bit. One more important conversion formula is this one, the conversion between what's called radical form to rational exponent form. So if you see something involving a radical in our expressions today, the first thing you're going to want to do is probably change it so that there's an exponent so that we can use properties of exponents to simplify. The trick is whatever the index is on the indicates the root, so like cube root. If you have a square root, remember you don't see it there, right? Like square root of x to the third. So if there's not an index there, it's sort of a hidden 2 there, but other than that, you should see a 3 or a 4 if it's indicating something higher of a root. But the trick is whatever that index is matches with the bottom of that fraction, and then the other power inside just goes on top. So that bottom example, that the square root of x to the third, I would write as x to the 3 over 2 because the index there was a hidden 2. All right, so let's take a look at some examples just rewriting. Looks like here we have rational exponents, but to be able to simplify and actually solve this out without a calculator, so that's going to be the challenging part. Notice all these are rational exponents, so it might be best that we might change this to radical form to see if we can evaluate. If I were to convert this first one to a radical form, what that's going to represent is, remember the bottom number is your index, so that's going to be the square root of 9 to the third. You can also write that as the square root of 9 raised to the third power as well. And so if I write it this way, notice that order of operations, right, square root of 9 is 3, and so the inside becomes 3, and if I cubed it, that ends up being 27. So 9 to the 3/2 power is actually 27, and we didn't need to use our calculator for that. Here, notice the next one, number 2, 81 to the negative 1/2 power. So the first step is maybe let's rewrite this as a positive power, which means I would write it as 1 over 81 to the positive 1/2 power. And if I rewrite 81 to the 1/2 power in terms of a radical, that's the same as the square root of 81, right? Anything to the 1/2 power is the same as the square root in math. So if I write it this way, then looks like my answer would be 1/9 here. So the next one's very similar. Notice we have a negative power. So the first thing is, let's rewrite this as positive power. One thing you can do is distribute both of the negative power, negative 1/2 power, to both top and bottom. So I can rewrite this as 9 to the negative 1/2 power over 25 to the negative 1/2 power. And since it's negative on top, so the 9 to the negative 1/2 power I can write on the bottom as positive, and vice versa. Since it's negative on the bottom, I can write that 25 to the 1/2 power on top. So that's going to be rewritten as 25 to the 1/2 power over 9 to the 1/2 power. And those are the same as the square root of 25 over the square root of 9 if I write it in radical form. Well, square root of 25 is 5, square root of 9 is 3, so my answer is 5/3. So let's take a look at here. We got a couple different examples. It says here we need to simplify with radical expressions. So notice we have some radicals involved. So it might be best that in order to combine this as one, let's maybe rewrite these as exponents first. So what we're going to be using here is that conversion property that if you have the nth root of x to the m, that you can write that as x to the m over n power as well. So in this first one, that would be the same as, the cube root of x would be the same as x to the 1/3 power. The fourth root of x to the 5th, I can write as x to the, looks like 5 over 4 power. Remember, your index is the bottom number in your fraction. And then that last term, since there's a square root here, that's a hidden 2 that I need to remember to write, but that would be written as x to the 3/2 power. Now that they're all the same base, you're multiplying those with exponents. That means we'd add those exponents together. So yes, we have to add with fractions. So our answer is going to be x to the 1/3 plus 5/4 plus 3/2 power. And in order to add fractions, yep, we need a common denominator. And it looks like the common denominator here would be in terms of 12ths. So that would be the same as x to the, looks like 4/12 plus 15/12 plus, if I change that last one in terms of 12ths, multiplying 6 to top and bottom, that gives me 18/12. And so if I add all my 12ths up together, it looks like I get an answer of x to the, looks like 37/12 would be my final answer. So in the next one, similar process, but we almost want to write this with a bunch of parentheses if you have sort of a composition of a bunch of radicals. So here we have the square root of the cube root of the square root of x to the 5th. So remember, these are hidden 2's here. So if I start in the inside, that can be written as x to the 5 over 2 power. And since you're raising that to the, or sorry, you're taking the cube root of that, the cube root of that is actually the same as 1/3 power. And if you're overall, the big encompassing one on the outside is the square root. And if I were to take that square root, then that's the same as taking that to the 1/2 power. So what I've done is just rewritten it with parentheses and exponents here. And remember, anytime the exponents are outside the parentheses, that's when we multiply these fractions together. And if you multiply fractions, guys, we just multiply straight across the numbers. So on top, I get 5 times 1 times 1, which is just 5. On the bottom, I get 2 times 3 times 2, which ends up being 12. So x to the 5/12 would be my final answer there. So take a moment, see if you can try these 4 on your own. So you can pause the video, work these out either on your desk or in your notes. But we'll take a look at these here in a little bit. Good luck. So in the first couple, very similar to the slide before, where you would want to first convert these to powers. So that first one, square root, that can be written as x to the 1/2 power. And then notice here we have the square root of x cubed, so that would be x to the, looks like 3 over 2 power if I converted that to an exponent. And then the last one would be just quickly x to the 4 over 3 power. And again, since we're multiplying, that's when we're going to add all the exponents together. And in order to add 1/2 plus 3/2 plus 4/3, I'm going to need common denominator work. And it looks like the common denominator would be 6. So to change 1/2 in terms of 6, that's the same as 3/6. If I change 3/2 in terms of 6, that's the same as, if I multiply 3 to top and bottom, that would be 9/6. And then the last one, if I multiply 2 to top and bottom, that ends up being 8/6. So it looks like my final answer would be x to the 3 plus 9 is 12 plus 8 gives me 26. That reduces to x to the 10/3. In the next one, you're putting a series of parentheses and starting from the inner part. So if I look at the first one, the cube root of x to the 6, that's the same as x to the 6/3. And then I'm actually taking that answer to the fourth root, so that means that's the same as 1/4 power. And then the overarching, looks like we're doing a square root of everything. So if I change that to a power, that's the same as raising it to the 1/2 power. And remember, anytime you are dealing with parentheses with exponents on the outside, then that means we multiply all those numbers together. I would definitely change that 6/3 to become 2 to make my life easier. And so now it looks like I'm taking 2 times 1/4 times 1/2. And if I multiply straight across, that gives me, looks like x to the 2/8, which is the same as x to the 1/4 power. So that's what you should have got for number 2. Number 3 and 4 are meant to not use a calculator. However, you got that calculator support to check your answer, okay? But if I were to convert the 16 to the 3/2 power back into radical form, that might help me simplify this. In fact, that's the same as the square root of 16 to the 3rd, or better yet, the square root of 16 all raised to the 3rd power. If I look at it this way, square root of 16 ends up being 4. And now 4 cubed, if I did that on my calculator, 4 times 4 times 4, that ends up being 64 as my answer. So 16 to the 3/2 power you should have got is 64. In the next one, we see that there's a negative exponent, so the first step is to write it as a positive exponent by writing it on the bottom. And then in order to simplify this, let's convert that bottom to a radical. So that would be the same as the cube root of 27 squared. Well, the cube root of 27 is 3. And so it looks like I get 1/3 squared, which is 1/9. So you should have got 1/9 for the answer for number 4. So this concludes part 1. What you can do now is try problems 1 through 9 on your worksheet. The worksheet's going to be due Wednesday of next week. After you practice those problems, you can jump to the part 2 video and finish your worksheet for the remaining part of the hour. Have a great day.